Okay, welcome back. So this is another example. We want to find the relative extrema. Remember that means max and min for this function here. 2x squared minus x plus 7 over x minus 1. Now, I actually did the division here and I wrote it this way. You know what? Let me bring this down, make that clear. 2x plus 1 plus 8 over x minus 1. It's the same thing. You just have to do the polynomial division or synthetic division, and that writes it this way. Either way, though, if the problem gives it to you like this, well, remember the first step here. We want to find the maximum or minimum. That means we need the critical numbers. So as a first step, let me try this. We want to find the critical numbers for this function. So that means we need to find the derivative. And my pen is not working here. Okay, here we go. So f prime, find the derivative. Well, see, in this form we would use the quotient rule. In fact, I don't think we have a choice. We would use either the product rule or the quotient rule. In this form, actually, we need the quotient rule anyways, because this is a rational function. So if it's all the same to you, I'm just going to use the first version of this, right? So remember the quotient rule, low d high minus high d low. That means denominator times the derivative of the numerator. And I'm going to do this all at once. By now, you should be very comfortable with taking derivatives. The derivative of the numerator is 2 times 2x, or 4x, minus 1. The derivative of 7 is 0, right? Minus numerator times the derivative of the denominator, right? So the numerator is just this, 2x squared minus x plus 7, times the derivative of the denominator. The derivative of x minus 1 is 1. Right? All over the denominator, oh, sorry. Let me try that again. All over the denominator squared. And so that's the denominator squared, right? So that's the derivative. Now that's not very pretty, right? So we should simplify it. We should go one step further here. Multiply out the numerator. I'm getting used to the pen here. Okay, multiply out the numerator. We're going to get 4x squared minus x minus 4x is minus 5x. Right? When you FOIL. And then negative 1 times negative 1 is positive 1. So that's positive 1. All right, and then let's just distribute the negative. Minus 2x squared plus x minus 7 all over the denominator squared. All right, and combining like terms, we get 2x squared minus 5x plus x is minus 4x. Sorry, that's a 4. And then 1 minus 7 is negative 6 over the denominator squared again. Okay, I think we can do one better. We can factor out the 2 on top, and leaving us with x squared minus 2x minus 3. You can see where this is going, right? Remember, that's probably the, well, there's one other way I can write the second derivative, the first derivative. 2 times x minus 3 times x plus 1. Okay, that's its fully factored form now. Okay, I'll just pause for a minute here, make sure everyone's okay with this so far, right? All right, so what are we doing? We found the derivative, and we're looking for the relative extrema, maximum and minimum. Well, right, it's where the derivative is either 0 or fails to exist. So let's start with the easy question, where does it equal 0? It equals 0 where the numerator is 0. Right, where's the numerator 0? At x equals 3. And x equals negative 1. Right? That's positive 3 and negative 1. Not at 2. Remember, 2 is just the coefficient. 2 is not a critical number here, right? It's part of the derivative, but you can divide by 2. It's not going to affect the sign here, right? All right, so those are critical numbers where the numerator is 0. What about where the denominator, right? So the derivative will not exist, right? F prime at 1 does not exist. Right? And now you might think, well, then x equals 1 is a critical number. Now, be careful. What is a critical number? A critical number is a number, right, an x value, where the derivative does not exist and that's in the domain of the original function, right? Here's the original function, right? This thing up here. So notice that in the denominator you have x minus 1. If you try to plug in 1 into the original function, you're going to be dividing by 0. This does not exist either. This is, well, specifically it's undefined. So 1 is not even in the domain of the function. And if it's not in the domain, it's not a critical number, right? So there's actually only two critical numbers, 3 and negative 1. 1 is not a critical number, right? Okay, so that's our first step. We found our critical numbers. These are critical numbers, negative 1 and 3. And remember, to find the maximum or minimum, we use the first derivative test. So for the first derivative test, we draw a number line and mark off the critical numbers, negative 1, positive 3, and that divides the line up into 3 segments, right? Remember the 3 segments, negative infinity to negative 1, sorry, negative infinity, negative 1, negative 1 to 3, and then 3 to infinity, right? So on each interval, we want to determine the sign of the derivative. Is it positive? Is it negative? So let's start with less than negative 1. Pick your favorite number less than negative 1. So I'm going to pick negative 2 and plug that into the derivative. And this is, sorry. This is probably the form of the derivative I'm going to use. Make it easy. So 2 times negative 2 minus 3, it's negative 5. And then negative 2 plus 1 is negative 1, divided by negative 1 minus, negative 2 minus 1. It's negative 3 squared. So you're going to get 10 over 9, which is positive. So that means this is going to be positive everywhere less than negative 1. Right, so remember, at negative 1, this is 0. And at 3, the derivative is 0. So we know the derivative is positive. It's increasing. So what happens after negative 1? Pick your favorite number between negative 1 and 3. Actually, before I do that, hang on. There's an issue here. Even though we said 1 was not a critical number, it's actually a very important number. Remember, if we plug in 1 in the original function, it's undefined there. What does that mean? Well, if the denominator is 0 and the numerator is not 0, that means you have a vertical asymptote, right? And so what happens at a vertical asymptote? Well, the derivative might change sign. So I'm going to put a little u here for undefined, meaning 1 is not a critical number, but we do have to use that as a dividing point. When we determine the signs of the derivative, you can see it might actually change here. From less than 1 to bigger than 1. I don't think it does in this case, but you never know. It might. We have to check, right? So between negative 1 and 1, I would pick 0. Plug that into the derivative here, and we're going to get, let's see, 2 times negative 3 times 1. I'll write it down. 2 times negative 3 times 1 divided by 0 minus 1, negative 1 squared. So that's just going to be negative 6, which is negative. So here, it's going to be negative. What about between 1 and 3? So between 1 and 3, the obvious choice there would be 2. Plug that into the derivative. So you're going to get 2 times 2 minus 3 is negative 1. And then 2 plus 1 is 3. And then, let's see, 2 minus 1 is 1. 1 squared is, well, 1. So I think we get negative 6 over 1. It's still negative 6. It's still negative. So as it turns out, right, the sign of the derivative did not change at 1, but we didn't know that beforehand. We do have to check, because in other problems it may change. And that will influence whether, the signs here are positive or negative. So yes, be very careful. Even though 1 is not a critical number, it's a number that you have to divide the line up into. And in fact, maybe some people may call that a critical number just because of that. But if you follow the definition of a critical number, right, a critical number is a number in the domain whose derivative does not exist, and that does not qualify as a critical number here. Okay, we have one more interval. Greater than 3, anything bigger than 3 would be, well, 4, 5, 6. I'll pick 4. Plug that into the first derivative, and you're going to get 2 times 4 minus 3 is 1, times 4 plus 1 is 5. Divided by 4 minus 1 is 3, squared is 9, so you get 10 over 9. 10 over 9 is positive, so it does change sign here, it is positive. Okay. All right, so back to our original question, find the relative extrema of this function. So now we have the signs of the first derivative, and now we just use the first derivative test. The first derivative test just says that if the derivative changes from positive to negative, you can draw a little picture here. Positive means it's increasing, negative means it's decreasing, and so that tells me that at -1 we have a relative maximum. So this is a relative maximum. What about -3? So at -3 it's going to be decreasing, or between 1 and 3 it's going to be decreasing, and then at x equals 3 it changes to increasing, and that tells me I have a relative minimum at x equals 3. All right, so just to finish off the question, we have a relative maximum. Let me try that again. Relative maximum at x equals -1. What would y be? So going back to the original function, if you plug in -1, you're going to get -2 plus 1 is -1 plus 8 over -2. So that's -1 minus 4. So I'm thinking -5. You might want to double check my arithmetic. I'm doing that in my head. And then where do we have a relative minimum? At 3. So relative minimum at x equals 3. And what's y going to be? Well, I'll let you do the arithmetic there. Again, you don't plug it into the derivative. You plug it into the original function to get the y coordinate. And what you should get is 11. Okay, so that should answer the original question. Find the relative extrema, or maximum minimum. And we have one of each. One maximum at -1 and one minimum at x equals 3. By the way, there's one good point about this question here is you have to be very careful, because I think if you looked at the previous problem, you might say, well, the maximum has a higher y value than the minimum. So all you had to do is really plug into the original function, get the y values, and say, well, you know, the y value here, I forgot what it was, I think 75 was bigger than 29. So that had to be the maximum, and 29 is lower, that had to be the minimum. And you can see that that's actually not true in some cases, right? So the y coordinate here is -5, right? -5, and that's actually smaller than 11. So if you only go by the y values, you might think, well, -5 is less than 11. That has to be the minimum. 11 is bigger, so it has to be the maximum. And as you can see, that's not what we get, right? So -5 at -5 is a relative maximum value. 11 is a relative minimum value. Okay, so this is a very poor graph in that sense, right? So well, if I can very briefly sketch the graph here. So at -1, say here's -1, we have a maximum at -1, and the y value is -5, so it'll be down here somewhere. So it goes up and then it comes down. So just to be a little bit better graph, remember at x equals 1 we have a vertical asymptote, so this keeps going down. And then the next critical number was 3, and y equals 11 is way up here somewhere, so this becomes not a maximum but a minimum. Vertical asymptote, and then something like that. Again, Very poor graph. But you get the idea, right? So you can't go by the y values. You have to go by the first derivative test and whether it tells you you have a maximum or minimum. So I just wanted to make that point to make that clear.